Vectors have a lot of new terminology, and so as I go through, you'll hear these different terms, and that'll be a lot easier than going through and labeling all the terms first. So first of all, the vector is the quantity that has both magnitude and direction. So there are two ideas, magnitude and direction. And magnitude is basically length, and direction would be like north, south, east, west. Now, you can measure different directions by positive x-axis. You can do it from the north-south line, and so it really depends upon the story problem that you're in. So you just have to read carefully with the words. Let me just talk about that a little bit. When it talks about bearing of that means that you're going to have a north-south and a certain degree, and then an east-west. And if it says heading, that means that you're basically talking about from the north line going counterclockwise. This is really important to remember because it can be easily confused as you start having terms thrown around like bearing and heading. So bearing is basically, it'll say it's either off the north end and then go east, or it would go west, or the south end, and it would either go east or west. So it'll make more sense as we go through. Let's take a look at some of these. This already says north bearing, so this is a bearing of north 45 degrees west. So I'm going to set up the north, south, east, west, and you're going to see from the north end 45 degrees, and that's going to be 30 meters. And that's how you draw that one. This one is different. It says to the horizontal. So you're going to draw a horizontal. Off of the horizontal, you're going to show that it's 40 degrees. And this is 150 yards. So that's a little bit of a drawing on bearing and off the horizontal. We still haven't gotten into heading, but that will come. Now you can also draw vectors. I'm going to focus on the triangular method on drawing vectors. And what you really need to remember is that you're talking about tip to tail. So that is the head and the tail together, and that's how you're going to want to draw them. So when you add them, it's going to be the resultant. That's a key word, resultant. So you're going to hear me say a lot, well, this is the initial vector, this is the impact vector, and this is the resultant. So you're going to start with something, there's going to be an impact like wind or current, and then the resultant, the true course of the particular object, would be the green one. Now, if the directions are just to draw this, such as draw vector n plus 2m, what you would do is you would put 2 m's onto that particular drawing, and then draw in the resultant. So that's going to be something like this. This would be your n plus 2m. Then what we're going to have are a couple examples, and again, just drawing, making sure we're looking at this. It says use a ruler and protractor. By now you probably hopefully forgive me for my my drawings because it's not easy to draw on here. But notice that it has nothing to do with my handwriting. It's just the way the drawing system is. But let's go ahead and look at these two questions. It says draw a diagram, and then it says show the magnitude of the horizontal and vertical components. All right, so this is, it says from the horizontal, so I'm going to drop a horizontal down, and the bearing, unfortunately, it says a bearing because it's not in bearing form, which is going to be off the horizontal. So that means that I'm looking at 120 degrees off the horizontal. And 120 degrees off the horizontal would go this way, And the question here is, if this is 7 inches, then what are the magnitudes of the vertical and horizontal? So I'm going to make a right triangle here, and this is going to be my vertical, and this is going to be my horizontal, and therefore I know that this right here is going to be 60 degrees, because 180 minus 120 is 60. Now I have a 30, 60, 90 triangle. So if you didn't have a 30, 60, 90, you would use SOHCAHTOA. But you do, and so I'm going to remember across from the 30 is 1, this is square root of 3 and 2. So that means that the horizontal is going to be 7 divided by 2, and the vertical is going to be 7 over 2 times radical 3. And I'm talking about inches here. And those would be magnitudes of the vectors, or lengths of the vectors. Similarly, you could look at this one. Now it has a bearing of northwest, meaning it's got to go this way, and off the north end 50 degrees. And the question is, if this is 2.5, what are the vertical and horizontal vectors, which means this is 40. Now I'm always going to the horizontal axis. That's really important to do when you're making these drawings. And so again, I could label this as my H and my V, and then the way that you would figure this out is the sine of 40 degrees equals V over 2.5, solve for V, and the cosine of 40 degrees equals H over 2.5 using SOHCAHTOA, solve for H. That's a little bit on drawing bearings, and also from the horizontal, looking at vectors, which include magnitude and direction. And the next lesson, we're going to be talking about some more complicated story problems.